Welcome to our webinar. It's the second part of our series of Git for Salesforce Admins, getting hands-on with Git. My name is Tina and I'm a part of the team at Gearset, and today I'll be taking care of the admin side of the webinar. As you guys know, today's webinar is live, so please take full advantage of this. Ask us all your questions in the Q&A box and we'll be sure to answer them as we go along. Today our speakers are Matt Dickens, Head of Marketing at Gearset, and Jason Mann, the Head of Customer Success. Over to you, Matt.
Thanks, Tina. Hey, folks. Yep, I'm Head of Marketing here at Gearset. I was also one of the co-founders. Don't worry about my Git credentials, though. I've been a professional developer for the last 10 or 15 years or so, and I was one of the original developers on Gearset itself. And over to Jason.
Yeah, thanks, Matt. Jason, I am the Head of Customer Success here at Gearset. So my role is to make sure that whenever people are using Git or Salesforce DX or source control or all that good stuff, we make sure we help them get the most out of it and get the most out of the platform as well. So cover a little bit of the agenda today, just give you a bit of a heads up on what we're going to talk about. We're going to talk primarily about a few main topics. The first one is a very quick recap of the key things we talked about in our first webinar, which was an introduction for Git for Admins, just to give people a little bit of a grounding in that if they haven't seen it already. Then we're going to do a bit of a dive into Git branching models and how they work. And from there, we're then going to build on working with the actual command line interface in Git, how you can interact with it, what are the common commands, and how can you actually wield them to work with source control from your local machine. From there, we're then going to dive into Salesforce DX and the CLI that they provide there. Again, we're going to step through the process of working with the CLI to create scratch orgs, link up a dev hub, log in, pull the changes down onto our local machine. And then we're going to actually do a comparison and see what does that look like when you're working with Git and Gearset through the UI. So you can have a bit of a perspective on what it looks like with command line tools and what it looks like with a third-party tool like Gearset. And then at the end, we'll do a bit of a wrap up, some key resources to look at, and we'll do our Q&A as well. So before we jump into the CLI and too much detail about working with Salesforce DX and Git, I want to do a very, very quick recap of the core topics we covered in our previous webinar. I'm not going to spend too long on it as we discussed them in length in our last session. And if you would like to see more of an in-depth discussion on them, then please have a look at our first webinar. We'll send the link at the end. That'll give you more of an in-depth chat into all these concepts. But the main things that we talked about were essentially what is a version control system, VCS. At its core, it's basically just a way to track changes to files over time. So whether you're looking at text documents or Salesforce metadata, version control systems just give you easy ways to see what's changed, when, and who made those changes. They also give you a suite of tools to manage conflicts between different versions, which help your teams collaborate and review their work, make sure you're not stepping on each other's toes, and help everyone understand what the current state and live version of a file is. That leads to a load of benefits. So there's things like easier collaboration between your developers and better visibility into the changes that are being made across your different estates, enabling parallel development streams so that you can have multiple teams working without stepping on each other's toes and release in parallel at different times. It gives you a really, really detailed audit trail so you can always trace back to any change, who made it and when, and what were the comments associated with it, so you can go back and make sure you've got that insight. It also really facilitates and encourages code review. So making sure that the team look at their code before it gets released helps you catch bugs, improve your quality, and just reduces the risk of you deploying changes that are broken, which means it removes some of the ceremony from releases, which is part of the concept of DevOps, of consistent, fast releases. And the final thing really it gives you is the idea of a single source of truth, which is essentially that everyone knows what version of a file they should be working on when they're starting a new piece of work. And gives you a nice place to roll back to if you ever have a disaster and you need to go back to a previous version. And the end result of all of this is really it gives you more resilience by making rollbacks more reliable and deployments easier and more automatable. So we also covered a little bit about what does it actually look like on Salesforce. Essentially, the main change is more of a mindset around traditionally you would have your production org as your source of truth where all your metadata lives. And if there was ever a disaster where production went away, you'd be in trouble. When you start to work with Git, really have to flip that and think, actually, my master branch in Git is my source of truth. This is where all my metadata lives. If I need to reseed an environment, I can do it all from my branch in Git. It's kind of a big difference in thinking, really, and it's something that Salesforce have actually started pushing quite heavily themselves since the advent of Salesforce DX. And you'll even hear them using terms like source fairly interchangeably with metadata in some of their DX documents and presentation. And that's because they're really pushing you towards this idea of source control, source of truth, and metadata should be in your source systems. And the final thing we touched on is really when should you adopt? And the really short version of that is now. Essentially, source-driven development is at the core of all the modern features that Salesforce are releasing on the platform, and it's going to be the future of development on the platform too. It's a well-established concept in other different platforms and software developments stacks. So really, it's something that's here to stay. And the sooner you adopt it, the sooner you can start to reap the benefits of automation, of that visibility, of the parallel development streams, and all that good stuff. So I'm not going to label those points anymore. Again, if you want more of an in-depth chat about that, then have a look at our first webinar. So what we're going to do now is we're going to build on the first webinar. That was a very theoretical session. We talked about the principles of what is Git, what is source control, what are some of the models to work with. Today, we're going to spend a bit more time looking at the practicality. We're going to look at popular Git workflows. We're going to jump into the Git CLI to actually look at those commands, how you can use them to track changes to files and commit them into branches, work with locally hosted versions of your source control system. We're then going to look at the Salesforce CLI and again, introduce some of the key commands that are important to know about when you're interacting with that. Pull down metadata from scratch org, spin them up, work with dev hubs, all that good stuff. And then we're going to dive into a demo of Gearset as well, so you can see what that looks like from a perspective. So the first stage we're going to look at is recapping some of the popular Git branching models to give you a bit of background on that. And for that, I'm going to hand you over to Matt.
Thank you, Jason. Okay, so I guess obviously here at Gearset, we talk to lots of different companies on a daily basis, and each one of those companies has its own release cadences and workflows that it follows. To accommodate all of those different types of workflow, the underlying tools themselves have to be pretty flexible too. And Git is not an outlier here. So there are lots of different ways for companies to use it, which is great for teams that are required to work in various different specific ways. But if you're just getting started with Git, this flexibility can make things a little bit tricky. It's sometimes unclear where to start or which approach to try first. At Gearset, depending on the company that we're talking to and their requirements, we tend to suggest starting with either the feature branch model or the Git flow model. There are lots of similarities between these two models, and we went back and forth around which one we wanted to speak about today, but ultimately we decided to focus on the feature branch model for 3 reasons. Firstly, it's the simpler of the two models, so that's a good thing. It's also the model that we use when building Gearset, so it's the one that we use the most heavily. And finally, the Git flow model actually builds on top of the feature branch model, so it's something that you need to understand anyway. Regardless of the workflow or branching model that you do eventually choose to use, there are a handful of underlying commands that are useful to anybody working with Git. So whether you're working with the CLI or a GUI tool, it doesn't hurt to be familiar with the basic Git commands that are being run behind the scenes to help you be confident in what it is you're doing when you're clicking around a UI. So let's recap that feature branching model a little bit because we touched on it during the last webinar. So the feature branching model is roughly defined as follows. There's a master branch that contains the latest state of your project and its full history. This should always be deployable with no failing tests or broken features. So if you find that a test fails when you try to make a deployment from that master branch, then you should prioritize fixing that failure case pretty heavily. As development takes place in a feature branch, you should never be making changes directly in master. It should all be via feature branches. So when a developer picks up a new feature or a bug fix, they create a feature branch from master with a descriptive name. At Gearset, we tend to prefix features with feature / and bugs with bug / to make it even easier to figure out what's going on. And then those features should be broken up into as small deliverables as possible. And those feature branches should be really short-lived. Again, with the Gearset example, we tried to make sure that feature branches don't live more than just a few days. If something's going to take longer, then we try to break that up into smaller bits of deliverable work and build those in their own feature branches. And the reason we do this is it's good to not have to wait long before pushing your work back to master for 3 main reasons, I guess. Firstly, you're deploying a small number of changes in one go. When you're working with short-lived feature branches. So it's less likely that you'll accidentally break something. And if you do accidentally break something when you're merging that back into master, it's much easier to figure out what the cause is because you've got fewer changes to check. The second benefit is that the rest of the code base will have changed less dramatically since you created your branch, which means that master and your feature branch will have diverged as little as possible. And that massively reduces the likelihood of merge conflicts, which can be a bit of a pain. And finally, you get to put the work that you've been doing in the hands of your users more quickly and obviously get feedback more quickly, which can't be a bad thing. Anyway, when a developer is happy with the change, that feature branch is then passed to a colleague for review. Usually this is by a pull request or the equivalent, depending on your Git hosting provider. Once that feature branch has been reviewed, any feedback has been given and responded to, it then gets merged back into master and then deployed out to any further environments for testing and release and so on. So this flow is really good because it means developers can work independently without having to worry too much about treading on each other's toes, because they're always in independent branches until the point that they merge. It also means that the development velocity is kept high because it strongly encourages changes to be deployed regularly by those short-lived feature branches. And that also has the benefit of taking the ceremony out of releasing, because releases are happening all the time, so they have to be well described and in fact even automatable. And that fact means that this approach lends itself really well to continuous integration as well. So before we dive in and take a look at how we do this in practice via Git and the command line, in the last webinar, we took a quick look at some of the tools that you'll need to follow this sort of workflow. So let's do a quick recap of that.
Thanks, Matt. So those of you who attended the last webinar may remember that we used a slightly strange analogy of a guy fishing from a pond to build tools for his DevOps toolbox, and what we need to put in place to actually put this in practice in our different environments. So what we're going to do today is very quickly revisit that model, as actually in the rest of the session, we're going to use these tools in practice. So this is the diagram from our first webinar. Essentially, this was the toolbox that we put together, which has 4 main categories of tool. So we have our Git provider, we have the implementation method, we have our DevOps tool, and we have the supporting tools. So Git providers, as we discussed last time, there's not that much between the main 3. You've got GitHub, GitLab, and Bitbucket. We suggested GitHub just because that's what we use internally, but there's not a huge amount between them. We did opt for the hosted implementation version as opposed to on-premise. Now, the reason for that is you just abstract away all the difficulties around managing your infrastructure, your scalability, software updates, security, all that sort of stuff. You're already using Salesforce as a SaaS platform, so you might as well be using your source control system as a SaaS platform as well. On top of that, you then have your supporting tools that you'd need to use to allow you to actually work with source control. This is things like your IDEs, which is an integrated development environment, essentially powered up text editors to allow you to work with code more effectively in source control systems. We have things like text editors like Sublime, which allow you to view that code in a little bit more detail. And then you've got things like your actual CLIs, like the DX CLI, which allow you to push and pull the metadata and interact with it. And then the final part of it was the DevOps tool. This is a tool that allows you to add in a bit of automation to streamline that process. Obviously, there's a few different tools out there, and relatively unsurprisingly, we decided to pick Gearset. But what we're going to do is show you how all of this could be tied together in the rest of the session so that you can actually see this all in practice. What I'm going to do is, beyond this theoretical example, we're going to start diving into this. So what I'm going to do is hand you back to Matt. He's going to dive into some of the Git commands, and then from there, we're going to build onto them in Salesforce DX as well.
Sounds good. Thank you, Jason. Okay, so to introduce some of these key Git commands that developers use pretty much every day, we're going to do it in the context of the feature branch model that we've just spoken about. Firstly, I guess apologies to those of you who are already experienced with Git. I don't think there will be anything new in this section for you, but hopefully at least it will be a nice reminder of some of those Git fundamentals. Firstly, let's take a look at the structure of a Git repo on your local machine. So if you were to dive into a local checkout of any Git repo that you've seen before, you'll notice 2 things. It'll be a folder essentially full of files, and the vast majority of those files in there will be a working checkout of that repository. So that's where you'll spend your time. It's essentially the branch that you're currently working on. Then there'll also be a hidden .git folder that lives inside that working checkout folder, and that contains a full representation of your entire repository, so all of the branches and their history. Okay, so now we can actually take a look at those commands that you'll need day to day. First, we're going to look at working locally, so how we can stage and add commits and move them around, and then we'll look at how we can share those changes with our colleagues by working with remote repositories too. Okay, so there are 2 main ways to get hold of a Git repository to start working in. The first one is to clone an existing repository, so that will usually be stored on a hosting provider like GitHub or GitLab, and then take a local copy of it. The alternative is to create a repository locally first, and then eventually if you want to share the contents of that repository, you can push that to some other remote later. We'll do that second thing. We'll start by creating a fresh repository locally. So to do that, first we need to run git init, which turns the current folder into a Git repository. So let's do that. I'm going to try and jump to a demo for the first time, so we'll see how this goes. So we're currently in one of Jason's folders on his hard drive. So first, let's just create a folder to run this demo in, and we'll change directory into that folder. Now we're in here. If I just run ls, we can see it's an empty folder. I'm going to run git init, and we'll get a response from Git saying that we've initialized an empty Git repository in here. Now, if we do a quick look at the contents of this folder doing ls-la, which also shows us hidden files, we can see that there's nothing in it except for that .git folder. So now we've got our repository, we can start making some changes. The first thing we'll need to do is make an initial commit, which will make our master branch and store our first change. So if I just jump back to the slides again for a second, this diagram gives you a rough idea of what's going to happen here. You can see that we've got a local repository containing a master branch, and we're going to create a single commit on it. So the first thing we need to do is actually create a file. So we'll jump back into our command line again, and we'll just do touch readme.md. So the reason we add a readme is it's pretty common for most repositories to have a bit of information as a starting point for anyone new to that repository. Readme is a good place for that. So we'll create our README file. Now we've created it, we need to commit it. So before we can commit it, we'll need to stage that using git add. So staging is a concept in Git, which is a convenient way of separating the files that we're ready to commit to our history from those that we're still working on. We can call git add with a specific file name. So we could call git add readme.md, or we can call git add dot to add everything that currently isn't committed. So I'll do the latter. The next command we'll use here is git status. So at any point that we're working with Git, we can call git status to figure out the current state of our working tree. This will tell us which branch we're currently checked out, which files have been changed, and then which files are staged to commit. So if we run git status here, we can see that we are on branch master. There are no commits on master yet, but we do have a new file that's staged to be committed called readme.md. Just as we expected. That's pretty great. So now we can commit it. So git commit is another command. This saves a snapshot of the working tree in its current state, taking into account everything that's staged, but ignoring any other changes. So when we commit a change, we annotate it with a message for our future selves or anybody else who happens to be collaborating on the project with us, so that the intent of the change is clear. So in this case, we've added an empty README file. So let's commit it with a comment to that effect. If I can type. Okay, and Git tells us that that README file has been committed. We can also run another git status here, and we'll see that we're still on branch master, there's nothing to commit, and nothing has changed between the current state of master and our working tree because we've committed all of our changes. So these two commands, git add and git commit, you'll be using on a very regular basis. These two alone give us the power to make changes and commit them to our repository so that we have a full history of all of the work that we've been doing. So they're really useful commands. If we think back to our original Git branching diagram that we showed when we were highlighting the Git feature branch model, and in the last webinar though, there are a few other crucial operations that we're still missing. Specifically, we can't create branches yet. We don't know how to switch branches or merge them either. So the next thing we need to do is look at using a feature branch to add some contents to our README file. So we'll slide it for a second. So the next step is to create a feature branch. The diagram on the screen here again shows you that we've got a local repository. It now has a master branch with a single commit in it, but then we're also creating a new feature branch called feature/update readme. So there are two ways that we can do this. Firstly, there is a command git branch, which will let us create a new branch. We can call git branch and then give it a branch name. Or we can use git checkout with an extra flag that will let us create a branch and change that branch at the same time. The latter is fairly common, so we'll do the same thing here. And then give it a branch name. We'll call this feature because it's a new feature that we're adding. And we'll call it update readme. Okay, and if we can see from Git's response here that we switched to a new branch that's been created. And if we run git status, we can see that we're on branch feature/update readme. Great. So the next thing we need to do is actually update that readme, and then we can commit those changes to that branch. So once again, if we take a look at the diagram here, our goal is to create a second commit on that feature/update readme branch that has no impact on the master branch, but contains all of the changes that we make to our readme file. So let's jump back to the terminal again, and we'll open up that readme file for editing. So I'm going to use Vim here, which is not always fun, but any text editor here will do. We just need to make a quick edit to this file. I'm going to just add a quick heading. This is a Markdown file, so I'll add a heading in Markdown that says expenses tracking app, because that's what our repo represents. And once I've done that, I will hit escape. I will write that, and I will quit. And now if I run a git status, we can see that that README file has been modified. But obviously, we've created a branch here to make a very small change. That's no bad thing. In general, branches should be really short-lived, as I've already mentioned. And more branches tend to be better than fewer branches, as long as they don't live for too long. That aside, we could have created a branch for something much more complicated, like adding a new feature to an org, and added lots and lots of commits to that branch before it was ready to be merged. Okay, let's actually do the operations here. So if we do a git add again, and if we run another git status, we can see that that README file is now staged for commit. And then we can do a git commit with a message of add content to README. And Git tells us that one file has changed with one insertion to that file. And if I run another git status, we can see that we're on branch feature / update README, and we're completely up to date. So that's great. Okay. So the next thing we need to do is figure out how to share these changes and then eventually get them merged back into master. On a real project, the responsibility for merging a branch back into master would fall to a colleague, or at least there'd be a process of review involved. You might be happy with your work, but it's important to get somebody else to review it first. This is usually handled by a pull request, or its equivalent if you're using GitLab and so on, rather than GitHub or Bitbucket. This is the way we're going to do it today. But that said, I wanted to introduce just a couple of other quick commands here, just to give you an idea of how we might do it without using pull requests. Git merge is a fairly commonly used command for things other than handling pull requests. So either for merging remote changes back into your own branch or for merging your changes back into master. If we were going to use git merge directly, we'd have to switch back to master using git checkout master, and then we can use git merge followed by that branch name. So in our case, git merge feature / update README to merge that feature branch back into master. And then all of those changes would be moved across onto the master branch as well. We're not going to do that today. We're going to use a pull request. So this means we need to start thinking about working with remote repositories. So we've created a local repo here, and we want to push our changes to a repo now hosted on a service like GitHub in order for our colleagues to review that work and ultimately take those changes and work with them. So first, we need to create a home for this on GitHub. So let's jump away from our slides for a second, and we'll jump into GitHub. We'll call this repository webinar demo. Once you've got a GitHub account, all you need to do is go to github.com/new, and you'll be able to create a new repository. I'm going to create a new private repository here, just so nobody in the outside world can see it. This is just for me and Jason. And then I don't need to make any of the changes. We don't need to initialize it here because we already have a local repository that we're going to push into it. So I hit create repository, and GitHub will go away and do that for us. So now we have a Git repository hosted on GitHub, and they give us a few helpful bits of advice on how we can actually get the changes that we've made locally into that repository. So we've created a repository on our local machine. So what we want to do is push that existing repository from the command line. So we can see the commands here that we're going to need to do that. And this introduces a couple of new commands. The first one is git remote. So git remote isn't something that we'll use on a really regular basis. What it does is it lets you create a link from your local repository to a remote repository. And obviously, because we've created our local repository, we need to link that to our remote repository. So I'm going to copy the URL here, but I'll type out the commands by hand. So we need to do git remote add origin. So git remote add tells Git to add a remote, funnily enough. You then specify the name of that remote. Usually for your kind of source of truth central repository, origin is the term that we use. And then we need the URL of that repository. Okay, now we've added that, we can just type git remote, and we'll see that we've got a single remote called origin. This now means that we can push our changes to that remote and pull changes from it. And if we jump back to our slides. Okay. So the next thing we need to do is push our changes. In this case, we need to push both of our branches to that remote. So we'll do them one at a time to make it really clear what's happening. So first, let's just check out master again using the checkout command that we mentioned before. So we switch to branch master. We can now run a git status, and we can check that everything's up to date. And if we run an ls, we can list the contents of that folder, and we see there's just a readme.md file in it. Now, we can have a quick look at the contents of that readme file. Cat is a command line tool that just lists the contents of a file. So I'll just call cat readme.md, and we'll see that there's no output because that readme file is empty. Okay, so that's what we expect master to look like because we haven't merged our branch that has changes to the readme file yet. So let's push that to the remote using git push origin master. So git push is how we share our changes with the remote repository. We've already added the remote origin, so we just say git push, we want to push that to origin, and the branch that we want to push is master. So we do that, and we get a little bit of output here from the git command as it pushes those changes, and it's telling us that it's created a new corresponding branch on our webinar demo Git repository hosted in GitHub called master. That's great. So now let's check out our feature branch, which is called feature/update readme. And if we run an ls here again, we'll see that we've just got that readme.md. And if we take a look at the contents of that using cat, we can see that there's a single line of text in it, which is the header that we added on this feature branch. That's all great and what we'd expect to see. So let's push this too. So we can use what we started with before and do git push origin feature/update readme. And once again, Git will give us some output that tells us that there's now a new feature branch that's hosted on our remote repository. The remote here in this case is GitHub, and obviously they've given us a little recommendation that says we can now actually open a pull request for that new branch we've created by visiting a specific URL, and we'll do that in just a second. So those are kind of all the things, all of the commands that we need to be able to adopt that feature branch workflow. But the next thing to do is to actually run this pull request and merge. So if we jump back to GitHub, and if we refresh the page for our repository, we can see that we have added so this is the current state of master. We can see that GitHub itself here is saying, hey, you've got a new branch called feature/update readme, and there are some changes in that you might want to merge. So we can just click the compare and pull request button, and we can see exactly what's changed between the two branches at this point. We can see that we've just added this single line to that single file. At this point, we could hit create pull request, and we can assign that to our colleagues for review. And then our colleagues can, when they're happy with it, merge that, and that will get merged back into master, just as our diagram shows here. Okay, that's all we need, like I said, to be able to adopt this whole workflow. There are a couple of other commands that I want to mention before handing back over to Jason. So firstly, there's git fetch and secondly, there's git pull. These are really useful commands because these are the things that let your colleagues grab your work and work with it, and it lets you grab their work and work with that too, because at the moment we've only looked at patching changes back to the repository. The first git fetch lets us fetch all changes to a repository from that remote repository in GitHub. So note that fetch doesn't actually merge anything. Git stores all of your local branches locally in that .git folder, and it stores a copy of the remote branches that you fetched. So git fetch won't affect your working copy or any of your local branches. You'll need to merge those changes from those fetched remote branches or use git pull to change your local branches. So git fetch is a safe command to run. It's not going to do anything destructive. If you're working on a local copy of master then and you run git fetch, your working copy won't change at all. You then merge those fetch changes into your local working copy of that branch by running git merge origin/master. That said, it's actually fairly common to use git pull. So git pull is quite a lot like git fetch, but it takes the additional step of automatically merging the changes that you've pulled from the remote into your local repository. It's essentially the same as running a git fetch and then a git merge on a specific remote branch. The common use case here is to pull changes that a colleague has pushed to that remote repository. So if since merging our changes into master has moved on and we've not pulled those changes back yet, we can call git pull origin master, and we'll catch up all of those changes from master. And finally, just to recap the things that we've touched on so far, this is kind of the majority of the commands that a lot of developers will use on a daily basis. There aren't many more than this. So this is kind of the minimum that you need to know to be able to adopt a workflow like this. It's a little bit daunting at first, but there actually aren't that many. We've included a little bit of a sort of cheat sheet / recap here that lists all of those commands, what they do, and then little examples of how we've used them today. So for anybody who wants to kind of work through some of this stuff themselves, just let us know after the webinar and we can send you over the slide deck and a more extensive command recap sheet for you to play around with. And I guess without any further ado, I'll hand back over to Jason.
All right, thanks, Matt. So Matt has given us a really, really good overview there of the key commands involved with working with Git, how to use them, some good examples of pulling code, tracking it in Git, working with the CLI. But at this point, what we've talked about is how to work in Git and how to work with the files, but we're missing a key step here. At the moment, all of the configuration changes and the metadata is still in our Salesforce orgs, and we're still working on it in the Salesforce UI. So how do we actually make that leap from working in UI to pulling that source down onto our local machines so we can then actually start to track it in source control system? How do we actually interact with that metadata? And this is where the Salesforce DX CLI comes in. So I'm going to talk now a little bit around, firstly, what tools does Salesforce provide to interact with the metadata and for working with Git? And then secondly, how do we actually use them in practice? So similar to Matt's section, we'll be running through some commands. I'll be going through the steps step by step so you can kind of follow along afterwards. And again, I've got a little bit of a recap at the end of some of the cheat sheet of the things to follow through afterwards. So before we jump into the actual CLI, let's just do a very, very quick review of what are the tools that Salesforce actually gives you out of the box if you want to work with Git or source control. Well, the first one is change sets, which I'm sure is a tool that many of you will be familiar with. Essentially, change sets only works org to org. It has no support for the CLI or working with Git, so that's pretty much off the cards right off the bat. Traditionally, the second choice that you would have is the force.com migration tool, or sometimes known as ANT, which was a command line tool and allows you to pull metadata down onto your local machine using the metadata API. But essentially these days it's being deprecated in favor of the Salesforce DX CLI because it's designed around the old or the traditional metadata API format, whereas the DX CLI is faced around the new DX format. So we're going to leave that one for now because it's not really the future of where Salesforce is pushing that development. So that leaves you really with the Salesforce DX CLI. This is the new tool that Salesforce has provided. It's essentially force.com migration tool v2. It's a bit more powered up. There's some new commands. It allows you to work with all the cool new stuff that Salesforce DX brings in, like spinning up scratch orgs and working with the new DX format. And so what that's going to be, we're going to be using that to actually interact with our metadata. The only thing that I'm actually going to mention as well is the extensions here for VS Code, which is an IDE produced by Microsoft. These are provided for free by Salesforce, and they essentially act as a plugin to that IDE to help you interact with the Salesforce metadata and pull it down onto your machine. But they first require that you have VS Code installed, and they're kind of built on the same CLI commands under the scenes. So what we're going to do is we're not going to focus on that because it requires some extra proprietary third-party software, and we're just going to focus on the Salesforce DX CLI. So without further ado, we're going to select our CLI. What we're going to do is we're going to follow through creating a project. So the initial setup steps of creating the folder structure, sort of similar to initializing a repository and how we can work with the CLI. We're going to connect to a dev hub. We're going to spin up a scratch org. We're going to pull some source or metadata from it. We're then going to log into the org and make some changes, and we're going to pull down those changes to our machine as well. So there's a few steps that I am going to skip that I did. For those of you who in the UK know Blue Peter, things I did earlier. I installed my Salesforce DX CLI on my machine. You can just grab that from the Salesforce site there. It works on Mac and Windows and Linux. It's a really, really simple process. I've also enabled a dev hub on one of my orgs, which again is something you can do for pretty much any org. Just log into the account, search for dev hub under your setup menu, and you can turn that on. And also I had a quick skim of the CLI commands. Again, there's a developer Salesforce reference here, which gives you all the commands and how to interact with them, which is good. So the first stage of working with Salesforce DX, once we've got everything installed and set up, is to actually set up a new project. This is essentially creating our folder structure. It's setting up all the structure of files in our machine so that we can actually pull down the metadata into our local environment. Again, we're going to do this via the CLI in a similar sort of way to Git. And the command we're going to use here is force project create. This is kind of, it says on the tin really, it creates a new project for you. And there's a couple of different modifiers that you can specify. There is the name of the project, which is just something that you can reference so you know what you're working with. the directory, so where do you actually want to store this on your local machine, and then the package directory, which specifies if you're working on multiple unlock packages and things like that, where you're actually going to put that metadata in. So what we're going to do is we are going to bounce out to my CLI, and let's just clear all the work that Matt's done because we don't want to look at any of that. I'm just going to move my screen share. So the first thing we're going to do is we are going to move into my documents folder. Bear with me a second there. On my local machine. This is going to be the master environment where we're actually going to initiate our project locally. Once we've done that, we actually now want to set up our project. So we're going to use the SFDX force. I apologize in advance. My typing is not as accomplished as Matt, so apologies for the typos. Force project create, and then we're going to use our name, which we are going to call Gearset project, and we are going to set our directory, which is going to be SFDX, which is going to be the folder that's going to be stored in locally. And we're going to set the project name as, as Gearset. And we're going to hit return. This is now, bear with me a second.
Mr. Dash N.
Oh yes, I missed the dash N. There we go. This is the fun of live demos. You can tell this isn't pre-scripted. Right, so what we've done now is we've used the DX CLI to create a load of folders on our local machine. And Matt's been showing you pretty much how to navigate around using the CLI. I want to show you what it looks like from a slightly different perspective as well. So what I've got here is Finder on my Mac. I've got my documents. You can see we now have an SFDX folder. We've got my Gearset project, and within it, we then have my Gearset folder, main default, and then obviously you've got these empty folders here, which is ready to receive the metadata from the API, but there's nothing in there at the moment. So the next step we're going to do, now that we've got our project set up, is, well, we need to actually see what orgs we've connected to it. We need to get them in place so we can actually pull down some metadata from them. And what you're going to do here is use the, again, fairly self-explanatory command, org list. This just provides you a list of all the orgs that you've hooked up to the CLI via OAuth. So the first time you do this, it's going to return an error and there's going to be nothing connected. So if I go to force, my typing is a little bit off today, I apologize. Force org list, it's going to churn away. And in a second, it will list all of the orgs that I have hooked up to my CLI. So you can see in this case, I've actually got my dev hub hooked up. What we're going to do is we're actually going to assume that the dev hub isn't there, so we're going to create a new org from scratch and hook it up. So the first thing you'd want to do is you want to add a new connection to an org in your environment. And again, what you're going to do this through is the auth web login command. What this does is pops open a new tab in your browser. You then log into Salesforce pretty much as normal using a normal username and password via OAuth, and that'll then save the credential in the SFDX CLI so you can then use that in the future. So if I bounce back to the CLI, what we're going to do is SFDX, and we're going to go force auth web login. What this is going to do is bounce me out to a new browser in a tab in my browser. Normal Salesforce login page here, you can see with a bit of an extra in the URL, and I am going to add my dev hub and click login. Once this happens, this is just going to bounce me out to my org if Salesforce wants to play, and that's then going to save the connection locally on my CLI as well. So in a second, when Salesforce actually goes through the login process, you'll see that saved locally. Obviously, this is something you only have to do once. This will then save the credentials locally so you can reuse this without having to go through this login process every single time. Looks like Salesforce is being a little bit slow at the moment. Login is temporarily unavailable. This is a little bit unfortunate. Let me check one more time. This is the real fun of live demos. Hopefully, Salesforce has not decided to turn off its login flow. All right, that's fun. So normally that would log you into your org and then save the connection. What we're going to do is then you can come back to the CLI and you can say, list all the orgs that are connected to the CLI, and you'll then see that org connection listed as a new connection. It looks like everything is running a little bit slowly at the moment, which presumably is a little bit of slowdown on Salesforce metadata API side here. So apologies in advance that this is running a little bit slower than when we ran it through in the past. But what you'll see in a second is that that list of orgs connected comes up, and then you can see you've actually started to add it. While that's loading, what we're going to do is jump to the next step, which is you want to then give your connected org a name. Now, this is essentially a little bit of housekeeping. It's not an absolute requirement, but what it does is if you've got a whole pile of orgs you connected in the CLI, it makes it a little bit easier for you to actually identify which one you want to work with without having to remember all the complicated usernames. So the command you use here is the force alias set command. You essentially pick the alias you want to use and then use the username for the org that you connected into. So if I bounce down to the CLI, it is still churning through listing my connected orgs. This could be interesting. All right, well, we can stop that. And what we're going to do is do our SFDX force alias set, and then we're going to use devhub as the alias that we want to set in our org. And then I'm going to set my username for the devhub and hit enter. Oh, it seems to be working again now. So now you can see we've added the alias devhub for a connection that we've got there. And again, if you go back now to the force org lists, in theory, that will then return the list of connected orgs, and then you'll have the alias set. Obviously, you can do this for every org that you connect up, and that just means you've got a little bit easier to navigate around what you're working with. So now we've got a local project set up on our machine. We've got the folder structure created. We've hooked up devhub. We've given it a name, so it's easy to find. The next thing we want to do is actually spin up a scratch org so we can start working on some changes and then pull those changes down onto our machine. Now, this is a command you're going to be using a fair amount. This is the org create command, which again, it's fairly self-explanatory, allows you to create a new org. The two parameters really here that you want to define, and it's worth saying that for a lot of these commands, there are a whole pile of other things that you can add as well. So different settings and logging levels and things like that, which the documentation gives you full input on. But the ones that really matter here are the devhub that it's actually going to be connected to, because all scratch orgs have to be linked to their parent devhub. And then you need a definition file. So when you create a scratch org, you have to tell Salesforce what's the structure of the org, what features are enabled, what usernames, do there certain preferences and things like that. All of that get defined by a definition file. Now, normally what you would have to do is you would have to actually create a definition file by hand. You can grab some sample ones off some of the DX repositories online. What I've actually got here is one I created earlier. We have my scratch org def.json file. This is set on my desktop on my machine here. I can see here that I've got the name of an org, the country, the edition, and a few other settings in it as well. I actually used Gearset to generate this for me earlier in a couple of clicks rather than having to write it by hand. What we're going to do is, you can see it there on my desktop. I'm going to copy that, and I'm going to go back to my local project file, and we're going to stick our scratch org definition file in there. So now we have a scratch org definition file that we can reference. We can actually run this force org create command and spin up a scratch org with those settings. So if I bounce back to the CLI, and I can go force org create, and I'm going to use my devhub, jasondev@gearset.com, and I'm going to use my definition file, which is in the config folder, and it's called scratch org def.json. With any luck, if the CLI is not being too slow, hang on a second, I think I put that in the wrong folder. You're right, I haven't navigated to the right folder. So this is the fun of live demos for you. This is all planned in advance, by the way, just to show you what you can do if you don't know what you're doing entirely on the Salesforce DX CLI, or it runs a little bit slower than you're expecting. There we go. Right, now we're in the right folder. Now we can ask Salesforce to spin up our scratch org for us using the definition file. Now, usually, this doesn't take a huge amount of time. Based on the time it was taking me just now to list my orgs, this may take a little bit longer than expected. But what you should get back in 20 or 30 seconds or so normally is the message back from the CLI that the scratch org has been created, and then it'll be saved into our list of orgs as well. Now we're going to have to wait a second while this actually creates. Hopefully it won't be too long. But what I can do in the meantime is talk about what we're going to do next while Salesforce is spinning that up for me. What we can do is we can then rerun our org list command, and you can add the modifier -all. What this does is it will not just list the connected orgs, but it lists all the associated Scratch orgs, even ones that have been deleted or that are inactive, so you can see that full list. Now, we're still waiting for Salesforce to spin that org for us up, but once it does, you can then relist that. What we're going to do is we're going to skip that one while Salesforce works on it. So the next step that we want to do is once we have our Scratch org, we then want to actually pull all the metadata from that onto our local machine so that we can then track it and in theory then commit it into our Git repository. Now for that, what we're going to do is use the source retrieve command. So alongside this, you then have to tell Salesforce what is the Scratch org that you're actually retrieving that metadata from. So that's just the username for that org. And then again, you have a definition file that you have to use here to define what metadata you're pulling down. So those of you who have used the metadata API before, you're probably fairly familiar with the packaged XML file where you list the components you want to retrieve. Exactly the same here as you're working with the DX CLI. Again, this is something that you would have to create by hand normally. You have to create a package file which specifies which custom objects or components you want to pull down, which Apex classes, things like that. What I happen to have here is, oh, that's good, the DLI. CLI seems to have given up. We'll run that one again. I do have a package file created locally on my machine. Again, this is a super simple one. All we're doing is we're going to say, I want to bring down the account custom objects using v46 of the API. What I can do, just similar to before, is I can grab my package file, and I'm just going to move that into the top level of my project. So this is the point where I would normally say, let's log into our Scratch org and we can start making some changes. We're still currently actually waiting for the CLI to spin up a Scratch org for me. So what I'm going to do is I'm going to give it about 10-15 seconds to do that. And in the meantime, I'm going to look at a couple of Q&A questions that have come through. And with any luck, if the demo gods are feeling good and the CLI is actually behaving, then we'll have a Scratch org in a second we can work on. So we have a couple of questions in the Q&A. Tina, are you able to run us through those so we can answer them while we're just waiting for the CLI to spin this org up for me? Oh, I think we may have lost Tina as well. It seems like it's everything working against us today.
Hello?
Hi.
We have Tina.
Sorry. The question from Philip Hirons is, can you alias in the create command?
That's a good question. You know, I'm not sure off the top of my head. That's something for Google to answer, I'm afraid. I don't actually know. Jason, do you know if you tried to do that before?
I haven't, I must admit.
Sorry, we failed you.
Then what is the difference between DevHub and a Scratch org?
So a DevHub essentially acts as, I guess you can kind of think of it like a licensing org that manages all Scratch orgs associated with it. So sort of similar where, you know, if you're working with a change set, you have to have your orgs linked to a production org just so they're kind of tied together. When you're working with Salesforce DX, you have this concept of a DevHub, which is, it can be pretty much any org. So in this case, it's actually just a developer org I'm using that I've turned DevHub on. And then every Scratch org that you create is then tied to that DevHub. And there are certain restrictions around the amount of Scratch orgs you can create and things like that, which are tied to the licensing level of the DevHub org that you're hooked into. There's nothing particularly special about it. And creating the Scratch org doesn't actually have any impact on the DevHub. There's no sort of metadata switch or anything between them. There's just essentially a licensing link between the two.
Thanks,
I'm going to give this, no problem. I'm just going to give this one last chance here, but it looks like the Salesforce DX CLI appears to be having issues. So we're going to assume that we have logged into our Scratch org. What we would then do is grab some metadata and then pull it actually locally onto our machine. Can't actually show you that right now because I can't actually create the Scratch org, but essentially the command that you would use is the source retrieve command. Similar to the login command here, you're just specifying with Salesforce what's the username of the org we're pulling the metadata down from, and then what's the package file you're going to use to define that. Once you plug that in, you hit retrieve. Salesforce will then create that metadata for you and pass it down onto a local machine. That will then populate into our folders in the project structure here. So you then start to see these folders fill up with Apex classes and objects and fields and things like that. What I was then going to show you, once we've done that, is actually make a change in our Scratch org and pull that change down onto a local machine. So you can start to see what it looks like actually working in an org, running those commands, pulling changes down and tracking them. And obviously from there, once you have that link of I can log into an org, I can add a field, for example, or change some permissions, I then know how to pull them down onto my local machine. Then we can hook them into the commands that Matt was talking about earlier and then say, well, now I can actually commit them into a branch in my Git repository. Pull requests, I can get them reviewed, and I can actually start to feed them through that end-to-end lifecycle. So I'm going to give it, there you go, one more chance. So you can see we have successfully created our Scratch org. So what we're going to do now is, very quickly, we're going to log into our Scratch org. So I'm going to go back to the force org open command. So before I do that, let me just show you the force list all. So you can see I've got my dev hub and I've got my Scratch org here. Actually, I've created both of them by the look of it, so I got there in the end. What we're going to do then is we're going to log into our Scratch org. So we're going to do force org open, and we're going to set the username as this top one. So I'm just going to copy that. And I'm going to hit return. And you can see this is going to pop me open in my browser and log me into essentially a standard environment that I can go and now make changes in. So I can now log in, I can go to my setup menu, I can add fields and things like that, and I can then pull that metadata down into my local environment. For the sake of time here, because we lost a little bit of time there waiting for the CLI to actually do things, what I'm not going to do is make a change and pull it down. I'm just going to use our package file to actually grab that metadata and just show you what it looks like locally on our machine. So apologies for bouncing around there between a few different slides. What we're now going to do is use our source retrieve commands to request the metadata from that Scratch org and pull it onto our local machine. So again, if I bounce to the CLI and I do force source retrieve, and I'm going to specify my Scratch org, which I have still pasted, and I'm going to define my package file, which is the one that we added in our top level, and assuming I'm in the correct folder, this will then request that from Salesforce, and it's going to start populating all of that metadata into my local machine. Now, there you go. Looks like it's working pretty nicely. You can see you've got the list of metadata we pulled down there from Salesforce. And if I now bounce back to my folder and I go to my objects, you can now see we have a new folder called accounts, and we actually have all of the metadata there from our account object, which is defined by the package file that we worked on. So I'm not going to go through the changes of actually making a change and re-pulling it down for the sake of time, but you can see what it looks like there to actually work with the CLI, create a Scratch org, and then pull that metadata locally, and then obviously you can start to work with it from there. We got there in the end. Well done, Salesforce. So what I'm going to do is a quick then recap of the commands that we have talked about here. So you've got your project create command, which allows you to create the new project and the folder structure on your local machine. You've got the ability to list connected orgs, and then the authword login to allow you to open a window and actually connect new orgs to your CLI. You've got the ability to set the alias, or the nice name, essentially, or the nickname for an org. Again, the ability to spin up a Scratch org using org create, using your defined package, your org definition file. The ability to pull the metadata, you can source retrieve, open an org using org open. And then what we didn't actually use is source deploy, which is then the final step of I've got my metadata locally on my machine, and I want to run essentially a standard deployment to push that into a sandbox or even your production environment using your pre-created package file as well. Now, there is a full link to all these commands in the Salesforce documentation, and obviously we can send around links afterwards from the webinar as well.
Okay, so now we're going to look at a few of the pitfalls outside of those of trying to run a live demo that talks to a third-party service that isn't under your control. Well done, Jason, on navigating that slightly tricky scenario. So I think we've demoed pretty much what you need end-to-end to be able to pull and push changes from orgs and then commit those to a Git repository and share those with teammates and get changes reviewed and so on. It's not always super easy. It feels very ironic talking through slides titled things like "It isn't always that easy" after the difficulties that we've just had. But there are some that are more specific to the problems that you'll face when you're trying to use these types of workflows. So I think the first one we mentioned is that there are still, I guess that Salesforce DX is still under active development, which means that there are still bugs and quirks that sneak in. So in fact, when working through this demo, Jason spotted one where he tried to specify a full path when initializing a DX repo, and it turns out that the command doesn't handle that situation very well and misses out the creation of some important bits of folder structure and project files and so on. These aren't super common, but because new features are released regularly, things are changing quite a lot. And before everything's in GA, there can still actually be changes that break backwards compatibility. I think we're at a point where, in terms of things being in GA, most of SFDX is kind of there or thereabouts now, but it's still under very active development. This also means that there is some limitations in documentation. So it can be a little bit of trial and error, and you might have to do a little bit of digging and Googling to get answers to some of your questions. I guess the next thing, and the one that we probably deal with on a sort of daily basis at Gearset, is the fact that the metadata API has always been a little bit quirky. So any of you guys who have worked with metadata before know that there are lots of interdependencies. So this means that deployments can fail if you miss a dependency. Obviously, you can mitigate this by having your devs and admins work in their own independent dev sandboxes or Scratch orgs rather than shared sandboxes to kind of keep their work separate, and then trying to keep all of your environments in as close sync as possible, so that when you're pushing changes to your Git repo from your org, you should be thinking more about the things that need to be excluded rather than the things that should be included. By default, you should be wanting to include all of the changes that you've made, except for things that maybe cause differences because of things like configuration differences between different environments and things. The quirky nature of the metadata API becomes slightly more problematic when you're using Git, because rather than going from org to org at deployment time, Git sits in the middle. So there's a period between pushing your changes to Git, merging into master, and then finally pushing those out to production. And then there's a longer period between committing changes and finding out that you've missed a dependency. So this is something that you need to be aware of. When you're going org to org, it's pretty obvious if you missed a dependency, because at the time you're trying to make that deployment, you'll get a failure case. You go back and tweak your change set or tweak your package XML for whatever it is that you're trying to deploy, and then push that again, and hopefully you'll get there in the end. If you're making those dev changes, then pushing them to Git, then it could be a few days down the line before they actually get pushed out to a test environment or to production, depending on what your workflow looks like. And that means you have to remember what changes you were making and go back and revisit that org and those changes, and make sure that you push those things that you're missing back into your Git repo before you can continue. I guess what I would say is that there are things like third-party tools like Gearset that can help catch things like missing dependencies. And there are also other couple of ways of mitigating that. So obviously short-lived feature branches with things like continuous integration can help speed up that cycle between pushing changes and getting them and running a deployment out to another org. Like any software as well, the metadata API does have bugs, and it also changes on a regular basis. So each release tends to introduce new issues that weren't there before, not necessarily major ones or showstoppers, but there can be things that change, and they're not always tied to the actual version that's being released. So there was a good example in the past few days where we know that there's a bug with site.com bundle retrieval via the metadata API, which can trigger a GAC under certain circumstances. So some of you might have already experienced that. If so, obviously don't try to receive site.com bundles for the time being. I know that there's a fix in progress at the moment. On top of that, some of the error messages that you can get can be pretty opaque. So it's fairly common to see things like unknown exception, unexpected error has occurred. In fact, that's one of the ones that we're seeing with the site.com bundles at the moment. Those are obviously hard to debug, and the only real sort of opportunity for resolution you have there is trial and error, and obviously getting in contact with support. I guess the next thing that can be tricky is if you're hand-rolling your own continuous integration server or something like that, then there will often be infrastructure to manage too. Obviously, that depends on whether you're self-hosting your CI system or using something hosted like CircleCI or Bamboo. But it's obviously fairly common for companies to have their own internal servers like TeamCity and things like that, which come with some management overhead. And then if you are using any form of automation, you'll need to maintain your own build and deployment scripts. So in working on Gearset, we found that using the raw metadata API, so just using the DX CLI naively, I suppose, just giving it metadata and telling it to push to a target, we found a deployment success rate of around 50% because of the quirkiness of the metadata API. We've put quite a lot of effort into finding workarounds for issues with the metadata API, and we've generally found that we can fix them with a reasonable amount of effort, but you have to obviously discover the the causes of those failures, think of workarounds and implement those workarounds. And in doing that, Gearset's managed to push its deployment success rate up to about 90%. But what that means is that if you're going to be hand rolling these scripts, then they'll probably grow into something more than just naive wrappers for the CLI. So they'll end up containing logic that will work around some of the edge cases that you'll no doubt encounter when you're working with the CLI and when you're working with the metadata API so closely. So that means that these will come with a burden of ongoing maintenance and development as well. And then one problem that isn't really trivially solved at all is merge conflicts. And this is common to all tooling, I would say. It's an inherent element of having multiple developers working on the same code base. We talked about it in detail last time and showed how merge conflicts can occur. So obviously, if you want to check back to the previous webinar, then go ahead and do that, and you can see us talk through it in some detail. But whenever two developers are simultaneously working on the same part of the code base, even with the best process, you'll occasionally end up with merge conflicts that need to be resolved by another human. So there's literally no way to automatically resolve every single type of merge conflict. Now, you can take actions to dramatically reduce the likelihood of them by adopting a branching model like the one we've spoken about today and making sure that your feature branches are as short-lived as possible so they don't have a chance to diverge. That means obviously splitting up features into small deliverable slices, which can be new to the way lots of teams operate, and it might go against perhaps the way the business as a whole operates if you're used to delivering large feature releases on a quarterly basis, for instance. There can be a learning curve there, but there are lots of benefits to doing that beyond making your merge and release process more straightforward. So we think that those small regular releases are something that everybody should aspire to. But I guess the thrust of the message there is you need to probably accept that there will be merge conflicts and then get familiar with how to resolve them. And again, if you follow those practices, you can definitely take the pain out of them. And I guess all of this then leads us to our last topic. So after the last webinar, we actually got a good number of requests for a demo of Gearset. We've been trying to keep this series as informative as possible, so we've been deliberately avoiding talking too much about Gearset, but this is actually a really good point to talk about how Gearset can help. So for those of you unfamiliar, Gearset's obviously a DevOps tool for Salesforce. It's specifically designed for Salesforce teams, and it makes it really easy to move changes between orgs and Git repos and move data between Salesforce orgs as well, and set up and run things like continuous integration jobs. So it can conveniently actually do all of the things that we've spoken about today, but without having to use the CLI, which is hopefully what Jason's going to demo now.
Thanks, Matt. So we've covered the CLI so far and how to interact with orgs through Git and in theory through Salesforce DX as well. But there's a bit of a steep learning curve to working with these kind of tools. There's no UI to help you through. You may have noticed there at one point I was in the wrong folder and I missed a M on the end of my username, which obviously causes issues and you get fake messages back from the CLI. Which means that it's not really accessible to everyone. You don't get visibility into what's being done. There isn't reports and things like that. And they generally rely on manual steps like creating package files, managing your definition files and things like that, which means that you can't necessarily pick them up and use them anywhere, and not everyone on your team might be able to get into them. So as a result, there's a fairly thriving market for third-party tools which build on top of these APIs to provide more of an end-to-end solution. This is where tools like Gearset come in. So what we're going to do is we're going to step through, in theory, the same workflow that we've covered between Matt and myself earlier, but entirely within Gearset and without touching the CLI once. So we're going to create a scratch org, assuming the API wants to play ball. We're then going to seed a repository from it, create a feature branch, work in our scratch org to make some changes, commit them into the branch, and actually end it then by opening a pull request, which obviously would be the point where you would peer review and then release those changes out. So without further ado, let's bounce out to the tab in my browser where I have Gearset open. So what we're going to do first of all is we are going to create ourselves a new scratch org to work in. So I've got my dev hub here hooked up in Gearset. It's called jasondev@gearset.com. That's the same one we were working in the CLI. What I'm going to do is I'm going to ask Gearset to create us a new scratch org, and we're going to call this something inspiringly named like Gearset Scratch. This is a really simple UI that allows you to use some of the core features like the addition and how long it's active for. You can actually specify complete creation options. Like complete creation within your additional creation option setting if you would like. Apologies, I think my audio might be very slightly breaking up. Bear with me a second. All right, I'm back. So yes, you can use the simple creation menu, or you can define the full options there, and you can actually use Gearset then to define and create your org definition file for you. I'm just going to use these basic ones. I'm going to click create scratch org, and what Gearset's going to do behind the scenes is run pretty much the same command that we ran earlier, ask Salesforce to spin up my scratch org, and then report back when it's done. Now, in theory, this again should be a pretty quick process. Based on the performance earlier, this may take slightly longer than normal, but once it's done, you'll then see that listed in our org. What we're then going to do once we've got our scratch org created is we're going to run a comparison from the new org into our source control system so that we can actually seed that source control system with all of the metadata from it. So again, we can start tracking changes when we work in it. So with any luck, our scratch org will be spun up in just a second, and then we can actually pull some changes and run comparisons to it. So it looks like the DX CLI is having a few little performance issues right now, which is that's part of the fun of doing live demos. But with any luck, we'll see that scratch org pop up in just a second. Perfect. Right, we have a scratch org called Gearset Scratch. So you can see there the edition, how long it expires in. If you want, you can even log into the org straight from here. Now that we've got that, we are going to work in a Git repository, and we are going to seed that Git repository with the metadata from the scratch org. So if I go to this other tab here, I actually have that repository open. You can see that it's essentially blank. There's the README file and a project file, nothing else in there. So the first step is run the comparison from our scratch org to that master branch of our Git repository. What Gearset's now going to do is it's going to pull the metadata down from our repository, and with any luck from our scratch org, start to pull it apart and build a comparison so we can see exactly what's changed between those two environments. It also does some cool stuff around tracking dependencies and making sure the shape of the metadata is correct. In this case, pretty much everything is going to appear as new because this is a blank repository pushing into, so there's going to be a whole pile of new items. What we're going to do is we're basically going to select everything and we're going to push it all into our repository so that we can then seed it with that metadata. So with any luck, this retrieve should be pretty quick. Again, we're slightly at the mercy here of the speed of the metadata API, but we'll then have that comparison in a second. Now, the reason that we're doing this is once we've got our repository seeded, we're then going to actually make a change in our scratch org in the UI. So we're going to, in this case, add a field to our account object, very similar way to how we were doing with the CLI. And then we're going to see how that diff falls through in Gearset. So you can see in my comparison results here, I've got changed, new, and deleted items. Everything here is new because this is a blank repository. I've got my custom objects, my fields, my profiles, all of that good stuff in the metadata. What I'm going to do is I'm just going to select everything here. There's no diff between the two because obviously it's just new. I'm going to hit next. Gearset's now going to take me through the process of building my deployment package for me. So I'm not having to build a package file here, for example, to run the comparison or to push this. I'm just going to select the components and then build them in. I can then add a friendly name to my deployment, which gives me a way of tracking it, a little bit like the sort of similar to the alias within the CLI, so you can give it a way of tracking it. And then I can add a deployment note here to my Git repository. So this actually becomes my commit message. So if I just put my commit message, this is then tracked in Git exactly the same way as when Matt was working earlier in the CLI and adding that commit message into each branch. I got a nice summary here of all the changes I'm about to push, and I'm just going to hit deploy. So what we're now going to do is we're going to build that file and we're going to deploy all that metadata into our master branch in our webinar JSON repository in GitHub. Once that completes, what I'm going to do is I'm going to bounce you out to Git so you can actually see what that looks like and then all the metadata as written in the DX format. And then we're going to actually start making some changes in our scratch org. So this will complete in just a second. We'll get a deployment report. This will show you what we've pushed, gives you a nice ability to download PDF reports and things like that. So one of the benefits that you get with a UI-based tool is there's an audit trail and you have reports and tracking and history and all that sort of stuff. When you're working with just a CLI, once you perform a command and you close the window, that's it, essentially gone. There's no way to check what did you push in the future. There's no way to share those reports with your team. So I can see here that deployment being successful. I can see I've added 300 new items. I can even see a list of them if I want. I'm not really that bothered about exactly what's changed at this point. What I want to do is bounce to my repository, and if I refresh it, what you will then see is I now have a folder, and within there I've got all my metadata. So I've got my objects, my Apex classes, I've got a count in here, for example. And then again, we've got the folder with fields and all the fields in it. So that's really cool. We've now pulled essentially all that metadata and pushed it into our Git repository in one fell swoop without having to go through the step of run the retrieve locally, then commit it using the CLI. What we then want to do is we actually want to make some changes in our org so that we can track those in Git. So what I'm going to do is I am going to go back to a new comparison, and I'm going to select my scratch org. And I'm actually just going to click login right here. And that's going to bounce me out in a new window straight into my scratch org so I can start making changes. What I'm going to do, again, a really simple example just for the sake of the demo, is I am going to add a new field to my account object, very similar to how we were going to work in the CLI. So go to my object manager, go to account, and we're just going to add a brand new simple field. We're going to call it a checkbox. And the field name is going to be Gearset without the CLI, something inspiring like that. I'm going to be very naughty and I'm going to leave no description here. I'm just going to set the profile visibility to standard and save that new field. Obviously, this is a pretty simple example of the kind of changes we'll be working in, but it gives us an example of how this workflow looks like. So now I've made my change in my field. What I can then do is I want to create a feature branch in source control so that I can actually track this change without committing straight into master, much like Matt was working on earlier. So if I go back to Gearset and I select source control, I've got here my webinar repository, and we currently only have master as our only branch. I'm going to create a new branch here, and I'm just going to call it feature branch. Again, behind the scenes, this is using the same commands as Matt was using earlier in the CLI, but you're doing it through UI with a couple of clicks. So we've now got that feature branch created. And what we can do is this feature branch is a copy of everything that was in master. So pretty much everything is in sync between these two, except we've now got the new field that we've added in our scratch org. So if we now run a comparison from the scratch org to our feature branch, what you should see is a couple of new items. And we're going to have our new fields, and we're going to have the profile changes associated with that field to affect the field level security. And we're then going to bring those changes and push them into our feature branch in Git. So again, what Gearset's doing behind the scenes here is it's pulling down the metadata from those both environments. It's looking at the dependencies, building that graph up, and then showing us that comparison table so we can see exactly at the line level what's different between those two environments. Now you can see here that the Git download is completed really, really quickly. What we're just waiting on here at the moment is that scratch org to give us that metadata over the API. That retrieval has succeeded. Gearset's now going to run the comparison, and we're going to see our comparison results in just a second. Now what we've got here is pretty much everything else is in sync as we would expect, because this repository was just seeded from our scratch org. But under new items, we have our new field here called Gearset without the CLI in our account object, and they're going to inspect the XML here. I'm going to select that. We then also have our field level security for each of our profiles associated with this field. So obviously with something like change sets, you'd have to push an entire profile. With the CLI, you'd have to pull apart the profiles and push which bits you like. What Gearset does for you is it makes it really easy to push just those granular changes. So I can select just the FLS here related to each of these profiles for this field, and it'll stitch all the metadata together for me at once. And we also got the permissions here for our layout associated with this. So I'm going to select all these components, and I'm going to hit next. Again, Gearset's going to build my package for me. I don't have to put a package file or anything like that. It's going to show me what we're about to push, and you can see we're going to push into our feature branch, and we can add another commit message. So this one is going to be something a bit more helpful, and we're going to call it something like adding a new field to account. And we're going to hit deploy. And this is then going to push all of those changes into my feature branch so that they can be tracked really easily. Once that completes, what we're going to do is we're going to bounce out to Git so we can then see those branches and see the change. And if we want, we can then actually open a pull request, which will then trigger the process of code review to get that change merged into master and then released out. So in just a second, you'll see the deployment report, just as before, show us what we've pushed. I can grab PDF copies of the report, so automatically get an email and things like that. So we've got really nice visibility. And if I now bounce into my Git repository, what it's going to show me is you can see our new feature branch here. If I want, I can even dive into the commit history for it, and I can see the new commit there that we did in Gearset. What I really want to do is open that pull request so I can review it. And I don't really want to have to bounce out to GitHub because it's another tool to use and learn. So for my deployment results in Gearset, I've got this button here that actually says create pull request. And I can just click that from within here. And I can say, what's the name of my pull request? Let's just call it feature branch because that's related to the change I've just made. And the target branch here that we want to merge into is master. I can click create pull request. Gearset's going to do everything for me behind the scenes. It's going to create my pull request and give me a link. And if I bounce out to that, we'll now be in our Git repository. You can see we're requesting to merge our feature branch into master. It's opened the PR. And again, you can go through this process that Matt mentioned earlier around peer review, making sure everything is good and ready to go, merging it and then releasing it out into our master branch. So that's a pretty quick work through of how you can work with Gearset and Git and the CLI. essentially what we've done is a very, very similar process to what Matt showed earlier and I showed just after him, but without working with the CLI at all. We've done it with a few clicks in the UI. We've had that diff and comparison as well, so it gives us a lot more visibility into what we're working on. So if I bounce back. So far, we've kind of covered a very simple example, but it's worth saying that Gearset works for teams of all shapes and sizes. The idea of the product is that it makes it really simple for not only devs who might be used to working with CLIs, but for admins or sort of other managers who aren't maybe so familiar with that technical side to actually get involved with the release management and have that visibility. And what we've got here is just a pretty small number of some of our happy customers across loads of different verticals, just to give you a bit of insight into the fact that this release management is appropriate for not just large teams, not just small teams, but pretty much anyone who works on the platform. So we've got global companies like McKesson, who are a Fortune 5 pharmaceutical company. They use Gearset across their entire suite of release teams around the world to make sure that we're powering their DevOps. You've got companies like Traction on Demand, who are the largest consulting partner in North America. Again, they've standardized to use us across all of their projects. Whenever they're implementing or changing Salesforce for their clients, they use us to manage that process. And you've got the other end of the scale, companies like Billy, which is a high-growth startup in fintech in Germany. And again, they want to make sure that they're using the best practice right from the start so that they can move fast and gain a competitive advantage and grow their business. Obviously, we have a whole pile more customers across different verticals like healthcare, finance, government, manufacturing, higher education, pretty much any environment you're looking at. They have the same sorts of challenges around visibility into what's changed working with source control and Git and the APIs. And so Gearset can help all those teams out. So if you missed any of the first couple of our webinars in the series, then it's definitely worth going back and checking some of those out so you get a bit more context on some of the things that we've talked about here. Things like what is Git from first principles, what are some of the benefits. We've got a couple more links here around some useful resources as further reading and recap on what we've talked about today. So Atlassian has some really good Git tutorials. There's also the Git book, and there's a Git branching site as well, which walks you through the process actually step by step, and it's a really good way to use it in practice. Unsurprisingly, Trailhead has a pile of really good modules as well, specifically written actually in collaboration with GitHub on what Git branching is and how to interact with Git and source control. And then on the CLI side for SFDX, you've got the actual reference list of all the commands, which is worth looking through because you can see how to work with them all. And they actually ran a really good series of blogs on the developer Salesforce site where they talk through what Salesforce DX is and how to get started with it in a 5-part series. And it's definitely worth having a read through those as well. And they also link you to some more Trailhead modules on working with source control and DX. So what we've covered today is quite a lot of stuff from scratch in terms of working with the CLI and commands and Git and source control. We've showed a fairly quick demo of Gearset. As Matt mentioned earlier, we wanted to make sure that this is really informative and we don't want to make it a big product pitch. If what you've seen does pique your interest and you want to learn more, then obviously you can go to our website at gearset.com and get an overview of the key features. We have more of our customer success stories at gearset.com/customers, and you can grab some of those to see how people are actually using our tool in the real life. We also have a really good selection of support documents which run through not only how to use the tool, but actually what is best practice in terms of release management, what are some of the key terms you need to be aware of, and how can you work with them to set up a modern DevOps process in your team. If you want to see a bit more of a tailored demo or spend a bit more time learning about the product, then feel free to reach out to us. You can send us an email to team@gearset.com, give us a ring. You can also contact us on any page in our site via in-app chat, and one of the team will get back to you. But really, what I would encourage everyone to do who has any interest is start a trial. You can just go to our website at app.gearset.com/create-account, sign up for 30 days, hook up a dev hub, create some scratch orgs, sign up for a free Git repository, and just start playing around. Become familiar with what it looks like to work with comparisons, deployments. Side by side, try out the SFDX CLI, start to see what works for you, what doesn't, and then take it from there.
Okay, and I think that just about wraps things up for us. So the last thing to say is that in the next webinar, we're planning to talk in quite a bit of detail about continuous integration and I guess wider automation around your Salesforce release process. We're not quite sure on the exact title yet, and we're not quite sure when it's going to be yet, but it'll probably be in the next month or so. So we'll be doing just the same as last time and reaching out to make sure that we let everybody know, and obviously we'll be sharing a bunch of stuff on LinkedIn as well, and hopefully some of you will be interested in and wouldn't mind coming along to that one too. All right, I think that's about it for us. So I'm going to hand back over to Tina, and I think we probably shouldn't spend too long doing questions, given we've overran by about 20 minutes. But Tina, if you've got any questions that you want to send our way, then we're more than happy to answer some.
Great. Thanks, Jason. Thanks, Matt. We have a couple of questions. I know we don't have too much time, so I've just chosen a couple. There's one from Alejandro. Is it possible or feasible to keep absolutely every part of an org, especially if large and complex, in a Git repo, or would some of it always stay in a dev or staging sandbox?
That's a really good question. I guess the aspirational answer is yes, it's possible, but the real answer that we see in 99% of cases is that there are always subtle differences, at least between a real world environment and a Git repo. So they might be configurational changes that differ between environments, where you have things like URLs or API keys or those sorts of things that you don't want to keep in source control because maybe they're sensitive and contain secrets that shouldn't be tracked by a version control system, or just because they're configurational differences, in which case managing those things becomes tricky. I'd like to think that going forwards, as the tooling improves and as the ecosystem improves, it will get more and more possible to include more and more things inside that Git repo. That said, you can get most of the way there. So it's not an excuse to not try, I would say. The approach that we always recommend is to start off firstly with subsets of metadata types that you're most interested in and get the team working with those, and then start adding in more types. And I think you'll probably get to a point where you find that you're capturing the vast majority of the changes that you care about in source control, if not all of the changes that you care about. And then it's mostly configurational differences that vary between the two and things that aren't changing on a regular basis. The only other thing I should say is that there are also still things that aren't supported by the metadata API. You can have a look at, there's a published report online on salesforce.com that will show you exactly which metadata types are supported by the API, and obviously all the other first-party Salesforce tools that hang off that API or that interact with it. And the DX team and Salesforce in general have been moving really quickly to expand support for that since the release of DX, but there are obviously still things there that aren't supported via the API that you'll struggle to keep under source control as well. So yeah, the short answer is realistically, no, you probably won't keep absolutely everything in your Git repo completely in sync with what's in your org, but it's a good aspirational goal and you should try and keep as much as you possibly can in there.
Great. Thanks for that, Matt. There are a couple of questions on code conflicts, and so we have a question from Ram. Does all metadata types supported by Git? How do we make sure conflicts while merging don't happen, as the metadata is a little quirky?
Good question. So there's no real great answer to this. The truth is that no matter what tools you use, there will always be cases where there will be code conflicts. So the question is, how do you then deal with those? Well, firstly, how do you minimize the likelihood of those conflicts? And then how do you deal with them when they happen? Firstly, the best way to minimize those conflicts is to use Git first and foremost. So if you weren't using a source control system and you were just deploying changes from one org to another, that's when conflicts can become really difficult, because they don't even necessarily manifest as conflicts. They manifest as, oops, I overwrote something in the target environment when I was deploying this large file that had multiple changes that I'd made, but somebody had also made changes that they'd pushed to the target. That's obviously the worst case scenario. So if you're using Git, then you already start to mitigate against some of those problems, because rather than pushing straight from one org to another, you end up identifying conflicts at the point that you try and merge your features, your changes in your feature branch back into master, and then you can see exactly what's changed underneath you, and you get notified at that merge time, which is a really great thing. Another important mitigation is to try and keep the life of your feature branches as short as possible. So I touched on this before, but the longer your feature branch lives, the more likely it is that firstly, master will have moved on before the point at which you try and merge it back in, which means that more files will have changed, which obviously means more likelihood of a merge conflict, and obviously then the more changes you will have made to your feature branch as well. So in my life as a software developer, my time at Gearset has been wonderful from a software development standpoint because we focus very heavily on keeping feature branches short-lived. And any feature branch that lives longer than a week is cause for concern. And then it's a point where we need to try and figure out how we can merge what we've already done without impacting our users and without having to ship a sort of half-working feature. So we have to try and scope the work that we do to smaller pieces. Whereas in the past, I've worked at other places where perhaps processes weren't quite so refined, where sometimes a feature branch could live longer. And the real pains crop up when you've got a feature branch that's lived for 2 weeks, 3 weeks, a month, and then you try and merge that back into master, because that's the point where suddenly you've touched quite a lot of files. There are large numbers of changes, and large numbers of files have changed underneath you. You end up with several merge conflicts. That can be really painful. And the other tricky thing is that they can be across bits of the code base that you haven't touched for a while. So if you made changes early on in your feature branch, shortly after you created it, and then you're 4 weeks in making changes and you're ready to merge that feature branch, it might be one of those early changes has conflicted with something that somebody else has changed underneath you in master in the intervening period. You've then got to get your head back in the space of those changes you made early on and figure out what it was you were doing and figure out how to merge those changes with what's changed in master. So the simple answer is that there isn't a simple answer. It's to keep feature branches short-lived and merge them as regularly as possible so that they've diverged as little as possible from master. And then how you do that is pretty much down to a kind of personal choice of tooling, really. So there are lots of great merge resolution tools out there. Some people like things like P4 merge. There's Sublime merge and things like that. But it essentially becomes an exercise of looking at those files, how they've changed, and then figuring out which bits need to be integrated together and which bits don't. I hope that helps.
Thanks for that, Matt. And the last question for this session would be from Pradeep Ghosh. I think this is on rollback. Once merge to master is complete, later someone decides to roll back or revert, how easy or difficult is that?
That's also a good question. It's actually quite straightforward. Git has a few facilities for handling rollbacks itself. But I guess there are probably three main ways you can handle this. Let's hope I can remember all three by the time I finish talking about the first one. So firstly, depending on the nature of the rollback you're making, it might be that you want that to follow your release process. So rather than making a change rather than doing that rollback change in that target org, for instance, what you could do is make that change either in one of the orgs that you were built that you're making developmental changes in anyway. So you can go ahead and update that org and then push those changes to Git just as you would, and then allow them to flow out through your release process into staging and production straight from your Git repo. That's one way. It's probably not the recommended way, but it's definitely a way that will work, and there aren't any major problems with it other than it polluting your Git history just a little bit. The other ways. So firstly, Git has two facilities for handling rollbacks. There is a command called git revert, which will let you back out a particular commit. So you can run git commit on any git revert on any of the commits that have happened that you want to roll back out. And then you can push the contents of your Git repo again back out to production to make sure they're absolutely in sync. And then you can also, in fact, in Git, just check out an earlier commit. So let's say the last three commits, you want to back those out. You can do a git checkout on a commit 4 commits ago by using its SHA hash. And then you can just do a git branch on that and create a new branch from that particular commit. And then you can push that, or you can even reset master's pointer, essentially, to point to that particular commit and then push that push that commit out as well. So there are a good number of ways, and Git's pretty well designed for handling these things, either by rolling forward and adding new commits on top of what you've already got in Git, or by backing those out using git revert or even just a straight git checkout. Hey, I hope that helps. And Tina, am I right in thinking that that's all of our questions for tonight?
That's right. We've covered the questions for today.
Perfect. Okay, well, in that case, I'll just say thanks again on my behalf, and I think Jason's headset's a little bit broken, so I'll say thanks on Jason's behalf too. He may attempt to crackle for you.
You can hear me all right? Thank you all for attending.
It looks like he's all working again. And now we'll just hand back over to you, Tina, to say thanks and goodbye.
Lovely. Thank you everyone for attending. Please feel free to send in all your questions, or if you need any more information. The best way forward is, if you're interested in knowing more about Gearset, is to sign up for our free trial and give it a shot. Use it in your own environments. Give us all the feedback you can on this webinar, and enjoy.